to another discrete math tutorial. In this tutorial, I really want to make sure that you guys have the logical equivalence laws solidified. So I'll probably spend the next couple of videos as well just doing numerous different examples and just kind of going through my thought process as I'm doing it. So let's start off with one. Let's say P and Q implies P. Start off something simple. Well, implication can be swapped to not P or Q, which kind of comes out to not P and Q or P, right? P implies Q is equal to or equivalent to not P or Q. So then we'll distribute the negation symbol in here. That comes out to not P or not Q or P. And then we can swap, because all the symbols are identical, to not Q or not P or P. And that comes out to not Q or true. Not Q or true is true. Let's go look at another one that's a little bit more complicated. Let's look at P and Q implies P implies Q. Interesting. So first we'll get rid of this implication symbol by doing not P and Q or P implies Q. Let's get rid of this implication symbol by saying not P and Q or not P or Q. Now let's go ahead and distribute this negation symbol in here. Well, that comes out to not P or not Q or not P or Q. Let's go ahead and swap these around a little bit. That comes out to not P or not Q or Q or not P. So not P or true or not P. Let's go ahead and just group this segment together first, just to keep it a little interesting. So not P or true, and then true or not P is also true. Let's do a couple more. Let's go ahead and do the negation of P implies Q also implies P. Well, I would, in this instance, work this portion out first. Or actually, well, let's go ahead and get rid of this implication first. So if we wanted to get rid of this one, it would be not P implies Q or P. The next portion that we're going to do, let's go ahead and distribute this in here. Well, not and not, that's just our double negation. So that's just P implies Q or P. P implies Q is not P or Q or P. And again, the symbols are identical. So that we can do not P or P or Q. Not P or P is true or Q. True or anything is true. So there we go. It is in fact a tautology. And I guess the last one we can look at is not P implies Q implies not Q. The last time we got rid of this one first, this time let's go ahead and get rid of this one. And just to keep it, just so you guys can see that you can do it in many different ways. Not P or Q implies not Q. Let's go ahead and distribute this inside here. So that becomes P and not Q implies not Q. Let's get rid of this right now. That comes not P and not Q or not Q. Let's move the negation inside. So that becomes not P or Q or not Q. Let's rearrange it to not P or Q or not Q. So that comes out to not P or true. True or not P is also true. And this one is a tautology as well. I hope you guys enjoyed this tutorial. Make sure to subscribe for more discrete math tutorials.